Unfortunately, there's a lot of truth to that. And much of that is because people go into recirculating aquaculture in general, unprepared. And by the time they've figured everything out reasonably well, they've lost all their money and they don't survive. Okay. So my career has been spent in terms of helping people understand aquaculture, particularly recirculating aquaculture systems, RAS, the acronym, before they spend too much money. And Etienne mentioned that we've known each other for a while. So I think it was maybe, was it 10 years ago, Etienne? I actually came and did a short course in Namibia. And
yeah, Mike, probably 10, 11 years ago.
Yeah, that was really good. So used the yellow book, same yellow book. And I think we had 100 people there or something like that. And we spent, I think, 2 full days, maybe 3. But my goal on those things is to help the student. I call everybody students. I'm a student. To get a better understanding of how these things work so that you can make good decisions. When you take my short course, I say, okay, you could design your own short course. I mean, you can design your own system, but maybe more importantly, you can work with your consultant and ask intelligent questions and actually discuss choices, and you'll have a knowledge base. Okay. So any questions? Sorry, no questions. Okay. So we'll get to the slides. I'll probably spend about 15 minutes here, just a little bit of an overview. As you know, I love to talk. I talk a lot. I got a bunch of visual aids here in case you want. So here's a question for the class. What is this? That's a red drum. That's a fish inside a fish tank. And so we might use this during the talk or in the Q&A session. And what is this? Okay, well, this is hydroponics. What is hydroponics? It is soilless. You see any soil in here? No. Soilless culture, and we put plants in there, and then they get all the nutrients out of the water. And we could do that inorganically or organically. We do it when we do it with fertilizer. We put some fertilizer in here. Okay. Stir it all up, see? Stir it up. That is soilless culture of plants hydroponically. Can't sell these as organic because we use fertilizers. When we raise fish indoors or in a controlled environment using RAS, we always like our water to look like this. Sometimes it doesn't quite look like that because what do? Whoa, 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 whoa. Got a lot of feed. Okay, I'm going to feed my fish today. See? Here's my feed. There they are. There's my feed. See in here. I could put some more feed in. Might fed too much, right? So in the fish only, some point I'll get to my lecture. When the fish eat the feed, they only assimilate maybe, at most, maybe half of the nutrients. And the rest of them are excreted across the gill as ammonia, or some may come out in the anal tract as excreted urea. And then we have, of course, fecal solids. Main goal in a RAS system is to get all that waste load out of the water so the water continues to kind of look like this. Okay. Well, all those waste products are actually nutrients. And guess what? If we would couple these things, the plants could use the nutrients from the fish, and then we have a sustainable system. So that's where I think we need to get to.
Mike, Etienne, just interrupting you there quickly. Your volume seems a little bit low. I don't know if you want to either turn up something on the PC or maybe you want to turn up the voice box in your throat.
A bit closer. Is that better, Etienne?
Yeah, much better. Thanks, Mike.
Yeah, there we go. Bonjour, bonjour, bonjour. Okay. Is that good? Is that nice, loud, and clear? That's good, sound-wise?
Thanks, Mike. That's much better. Thank you.
Yeah. Okay, great. So now we're actually getting into the lecture, 10 or 15 minutes here. I'm trying to make a case here for, and this is posted. This is a very short version of the longer PowerPoint that's posted. Anybody can use it. I had no problem with people using all my stuff. I think it's a compliment. So this is me. And let's see, page down. Okay. So, okay. Oh, okay. So Etienne. So next slide. Wise man was asked. This is actually a friend of mine. He was the president of the World Aquaculture Society. Can aquaculture rise to its potential? One of my friends that I was in business with, who says, yeah, aquaculture is the business of the future, and it always will be. He was a practical entrepreneur. We've been talking about this for 30 or 40 years. But now, maybe in the last 3 or 4 or 5 years, the technologies got to the point where it's reliable, cost effective. We still got a long ways to go, but we're kind of there now. Okay, so these things are real. The key, let me just add this too, is that one solution does not fit all, right? So what we do in Kenya, or what we do in Bonn, Germany, or what we do in Santiago, Chile, or what we do in Vero Beach, Florida, where I live, okay? Those are probably not the same solutions, okay? They're all based on the same principles as described in the yellow book, okay? But they're all different. Particularly, it's going to be related a lot to your labor costs, your raw inputs. If you approach that then mathematically, like engineers like to do, you'll come up with an appropriate solution for your particular situation, your particular location, and all the constraints that has, okay? So approach it fundamentally, and you'll get there probably successfully, okay? Next slide. So I like to say this, how hard can it be? I mean, raising fish in the tank. Right? We're going to the moon, right? We're joining people together in outer space, and we do that. But remember, we've had a few accidents, unfortunately. So think of how many engineers are behind one of these docking situations, and they still have an occasional accident. So you have to protect yourself and your investment, but bad things can happen. There'll be less bad things happening if you properly prepare, have good design behind you, and have a really good management team. Your chances of success are really high, okay? Next slide. So like I say, I took this picture, that's why I like to put it in there. That's one of my tanks and some of my beautiful tilapia. I mean, it can't be that hard, right? So key phrase here, controlled environment agriculture. What does that mean? I can grow anything you want me to grow, plant or vertebrate, fish. I can grow anything because it's controlled environment, okay? I did a 500-ton farm in upstate New York, which where the average temperature is 10 degrees C. In the wintertime, would not be unusual to have minus 20 degrees C. And what did I do? I raised a tropical fish. How smart is that? Well, geez, Dr. Timmons, wasn't your utility and heating costs very high? And I go, no, because I didn't discharge hardly any water. So if you don't discharge hardly any water, you can create the water with the water quality parameters you want for your species of choice, i.e. the ideal economic values, raise them, and you'll be successful, okay? For the record, my utility costs there were, the heating cost was like 2 or 3% of my total cost of production. So basically nothing. Okay, another little factoid. I used to raise a lot of money. In fact, I'm raising money right now through the farm I started in Vero Beach. And I would go to a presentation and say, hey, guess what? I can raise fish with no water. And they go, nah, you can't raise fish with no water, Dr. Timmons. Everybody knows that. I go, well, I use maybe 1/5000th of the water in my RAS that I would use if I was doing conventional fish production. 1/5000th. So I go, I use a little bit. So yeah, next slide. That was that particular farm upstate. It looks like a big dairy barn. Slide on the left, and indoors. It's basically what we would do for a dairy barn in upstate New York. I'm using at that point round tank technologies, series of steps: small fish, medium fish, big fish, harvest the fish. Recently, you can see down here Atlantic Pacific Jade in bold type. Started that January 2020. I got 8 employees. I have 2 websites that you might be interested in. They've got a lot more detail. I'm also in this new company, pretty active consulting division. I have a partner in South Africa. His name is Rael Zyle. It took me like 10 times to get his name right. Anyway, Rael, like real. So anyway, he would be a local contact for you to further investigate what we could do for you if you need any help. Okay, next slide. Real quick stat here. Go down to the 1, 2, 3. Let's look at the third bullet point. Seafood, the most globally traded protein commodity by volume of value. Amazing. Okay. Go down a few more bullet points. Over 75% of the fisheries are considered fully overexploited. That's a true statement. That's why we need RAS, where we don't have to keep harvesting the ocean in a non-sustainable manner. And then the next bullet point, 50% of all food fish supply comes from aquaculture. When I started, which was about 233 years ago, no, not that long. Okay, seriously, I got involved in it maybe 1983, 84, 85, in that range. And back then, only about 5% of our seafood came from aquaculture, and now it's over 50%. So it's because the catch, the wild catch from the ocean stays about the same. And then where do you make up the extra supply for the demand? Well, it comes from aquaculture. Anyway, it's going great. Next slide. Next slide. Yeah, it says the same thing. Next slide. Okay, a little information here. I love this stuff. Okay. So what should we, okay, we got to feed all these people. We're going to have another 2 billion people in the next 30, 40 years. Where's all that food going to come from? Well, somewhere, right? So what should we choose, right? So it's all about converting raw inputs into meat protein. So look at these numbers: beef and chickens and pigs and fish. You drop down the fish, look how much more efficient it is, right? Whoa. So common sense would tell you, well, let's produce fish as our protein source. And they are so much better, right? Because they're a cold-blooded animal and they don't use hardly any energy to maintain their body homeostasis set points, right? You and me, we got a body temperature of, 37, 98 degrees Fahrenheit, something like that. We're always losing heat to the environment, unless you live in a really hot place, right? And that takes a standing metabolism, and that comes from the feed, and that's why we're not very efficient. Okay, next slide. Next slide. Look at the amount of water that's being used. Just look at these numbers. I don't have to read them. Look at these numbers, how much water is used to produce food. So the obvious choice here is we want to do hydroponic or aquaponic type production, which uses very, very, very little water. Okay, so that's the direction we got. We got to go with fish, and if we want some nice vegetables, well, we got to do that hydroponically. And with my earlier visual aid, right, combine the two, and you have aquaponics. Next slide. Hey, welcome, Rael. Rael is here. Rael, he's the real deal. He's my partner in South Africa. Okay, some basics here, right? Whether you're doing a what we call a flow-through system, flow-through would be where the water with the big pink arrows that just goes through the tank, goes out and discharges, goes away. If we start to bring some of that water back, see the little loop at the bottom, we start to call that recirculating aquaculture, and that could actually be almost 100% of that flow. So very, very little is discharged, and almost all of it is recirculated. But the basics of how you control the tank and the fish inside the tank for water quality is we had to turn that tank over, i.e. flow it through 30 to 60 volumes per day, right? So in minutes, where we call, how long does it take to fill up the tank? It took me 30 minutes to fill up the tank if it was empty. So that 30 minutes is what we call the hydraulic retention time. And so hydraulic retention time on RAS or flow through, it doesn't really matter. It's going to be somewhere between 10 minutes and an hour. In RAS, we do not like to go above an hour because the water quality starts to suffer some. And I like, somewhere between 20 minutes and 40 minutes. Smaller fish, usually the HRT is shorter, better water quality, and bigger fish, it's longer because of engineering constraints. Okay. Anyway, that's what we do. We move a lot of water. And so before I forget, right, we actually have patented a new pump, and that pump moves. Most pumps will do 100 gallons per minute, 200 gallons per minute per horsepower per kW. The pump we invented will move 3,000 gallons per minute per horsepower per kW of energy input. So it's pretty exciting. I think it's going to change the way we actually can produce fish, because we can basically move the water around in this loop for free. It's almost no charge. And that's the advantage, one of the advantages of flow through, net pens and such. The water flows through for free. You don't got to pay for it. Okay, next slide. Okay, here's our basic mass balance on feed comes in. The fish absorbs certain quantities, then they discharge a whole bunch of it, and we kind of did the analogy with my little pictorials here. All these discharges are nutrients that could be used to support plant production. Next slide. The feed, typical feeds, they got all these macro and micronutrients, and back in the old days, what nutritionists do, no offense, right? They would just, particularly in the micronutrients, they would just give the fish 3 or 4 or 5 times what they needed. That would be to ensure the fish got what they required for cell building, and then the rest, of course, are discharged. Well, we can't do that anymore. So now the nutritionist is really, really tight, in terms of what is fed to the fish, but they still discharge probably half of it. So anyway, all these things are available to the fish, to the plants as in an aquaponic system. Next slide. There's the simplified version of what aquaponics is. I think I gave you a pretty good one with my 2 glasses of water. Yeah, it goes around in a circle. The plants tend to absorb nutrients. And interesting, like you can do a design where the plants completely assimilate all the discharged nutrients from the fish. So, hey, Dr. T, why wouldn't you do that? Well, the footprint of the plants is, 10 times or so more than the footprint of the fish. And that means the economic outputs are 10 or 20. So I figured it out once, and it's like on an integrated farm, like 95% of your cash flow would come from the plants and 5% from your fish. So it doesn't balance very well, right? So that's a challenge, of how you actually integrate these things and run a business. Okay, and that's another discussion. That's probably at least another 20 minutes. Next slide. There's aquaponics. Next slide. Some examples. Next slide. Yeah. So the take-home message here is hydroponics. It's very, very exact conditions, pH control, where aquaponics, you basically do nothing. You do nothing. You add chelated iron, and the aquaponic systems do just as well as the hydroponic systems, and that's based upon scientific research that I published. I didn't believe this. I just didn't believe it myself. So I finally got tired of all the aquaponics people saying, wow, my plants and my lettuce and my tomatoes, they taste better, they grow faster, they don't do anything. And I go, yeah. Where's your data? Oh, it's great. Well, I finally got tired of that. So I set up the control research and did it. So guess what? They were right. Next slide. This is just a complicated slide of its nutrients. Each have their availability based upon pH. And long story short here, on hydroponically, you tend to raise plants around 5.8 pH, and fish, of course, we like around 7. And it's very kind of complicated. So that's a chemistry lecture. Next slide. So we actually did some of this stuff. My lab manager for 3 years was Tyler Anderson, got his master's degree under me and managed the lab concurrently. He was really, really good. So you always, I publish a lot because I have really good people that I hire, and then they do it. Okay, and then I kind of watch. Anyway, he did some really nice stuff. Next slide. We did a lot of stuff on bib lettuce. Next slide. And this is what he found out. There's just, interestingly, you can study this a lot, and probably should get the paper and read it, but basically there's no difference. But here's the interesting part. If I took the nutrient conditions that exist aquaponically and I managed that hydroponically, the plants do not do well. That's what this is saying. That's the middle group there, the 23% reduction. Sometimes worse. I mean, it's just amazing. There's something that the system does through the fish gut, the microflora, the bacteria, that makes these nutrients more available to the plant. And I said, oh, so it's all that living. We actually ran another experiment where we killed all the living organisms in the fish water, and they did the same. It's amazing. That's a revolutionary paper. Next slide. So we also did spinach, same result. Next slide. There's some nice looking spinach, huh? Next slide. Next slide. Summary. Next slide. Next slide. Next slide. So what the short version of that is, we can use the roots. Aren't those beautiful? We can use the roots as the biofilter, and everything works really, really well. Okay, I wrote another paper on that. Okay, next slide. And there we are. Hope that didn't go too long. So that's me a couple years ago. Same hair color.